Greetings. In this short video, I will give you definition of discrete log and examples based on a prime number. Okay? So let's begin. Let P be a prime number. For us, usually this is an odd prime, usually 3 or 4 digits. And R is a primitive root of P. We talked about primitive roots in a previous video. So what it means is, if you compute R square up to R to the power of P minus 1. By the way, the moment I say R is a primitive root, obviously R is in between 1 and P minus 1. Okay, it's a positive integer between 1 and P minus 1. And when you try to compute all these powers, they should be equal to 1, 2, up to P minus 1. Obviously, we know that R to the power of P minus 1 is congruent to 1 mod P. All these powers are computed mod P. Okay? And we know that R to the power of P minus 1 is congruent to 1. That's Fermat's little theorem. Now, once you have a situation like this, once you have a prime and a primitive root, for any k between 1 and P minus 1, for any integer k between 1 and P minus 1, we can define log k to base R as follows. So before I define that, so we want to make sure, if you want to compute discrete logs, you got to have a primitive root and you got to have an integer k between 1 and P minus 1. And this R is known as the base, as usual, the notation for logs. And this k, we want to compute discrete log of k to base R. That's how we read this. We say log k to base R equals x if k equals R to the power of x. That's the definition. This is exactly same as the definition you would see in Calc 1, but here the main difference is the base is a primitive root of a prime, k is a number between 1 and P minus 1, and this x will also be in between 1 and P minus 1. Notice x mod P is a number between 1 and k minus 1. Okay? So all these things are integers. Now, the concept is easy to understand. How do I find this x? Because k is a value in between P minus 1 and P minus 1, k is in this set. K is in the set 1 through P minus 1. And that's also same as the powers of R. So really you're looking for, there's a k here, and there is R to the power of x here. So we need to look for x. When you raise R to that x power, you should get k. That x is your discrete log of k to base r. Okay? Let me give you an example how to compute this. Before I do that, let me say these are not easy to compute. A discrete log is very difficult to compute for large numbers. So the examples I give are fairly simple and you could do by hand. But in general, discrete logs are difficult to compute. That's what provides security in public key cryptography, the discrete logs. So here's an example. Example, let P be 11. So I'm taking 11 to be my prime, and 6 is my primitive root. Note, 6 is a primitive root of 11. Okay, so let me check that first. Why it's a primitive root? Because you gotta have a primitive root. That means I gotta compute all the powers of 6. 6 to the power of 1 is 6 mod 11. 6 to the power of 2 is 3. 36. 36 is 3 mod 11. 6 cubed is 7 mod 11. 6 to the power of 4 is 9 mod 11. 6 to the power of 5 is 5 mod 11. 6 to the power of 6, okay, I missed something here. 5 is 10 mod 11. 6 to the power of 6 is 5 mod 11. 6 to the power of 7 is 8 mod 11. 6 to the power of 8 is 4 mod 11. 6 to the power of 9 is 2 mod 11. Of course, we know that 6 to the power of 10 is equivalent to 1 mod 11. This is Fermat's little theorem. The last one is Fermat's little theorem. So as you could see, the powers of 6 generated all the numbers between all the 10 powers of 6 generated all the numbers between 1 and 10. So you have 1 here, you have a 2 here, 3, 4, 5, 6, 7, 8, 9, and 10. Therefore, 6 is a primitive root of 11. Now, I want to compute, let me write it here, I want to compute log base 6 of 5. So by definition, I said this is, if you call this as x, 5 must be 6 to the power of x. First of all, this 5 must be in between 1 and 10. Then only we could talk about discrete log for that number. And the base is 6. So log 5 to base 6 is x. So 5 is 6 to the power of x. Therefore, the question we're asking is, in this set, 6 to the power of 1, 6 squared, all the way up to 6 to the power of 10, we know that that's equal to 1 to 10. Which power of x, which power of 6 will give you 5? We want 5, and what's the power of 6 that gives you 5? So if you look at these calculations, 6 to the power of 5 is 5 to the power of 6. 6 to the power of what number gives you 5? Sorry about that. What power of 6 will give you 5? And if you look at this list, 6th power of 6 will give you 5. Therefore, this x equals 6. In other words, log 5 to base 6 must be 6. Understand? That's an example. Again, this is a tedious process, and we don't do it this way. There are certain algorithms to compute discrete discrete logs of certain numbers, as I mentioned in the class, but this is an example, and as I said, it's very tough to compute discrete logs for large numbers, and that's what provides security for public key cryptography. Okay, thank you.